Today's topic in industrial chemical calculations subject is mixtures and solutions. First, we will discuss about mixtures. A mixture contains two or more substances which are not chemically combined. They only have physical interactions. Since they do not have any chemical interactions in a mixture, the chemical properties of the individual substances retain without change. However, the physical properties like melting point, boiling point can be different in a mixture compared to its individual substances. So the components of a mixture can be separated using these physical properties like melting point, boiling point. For example, hexane can be separated from a mixture of hexane and water because hexane boils and evaporates before water does. So it means that a mixture can be separated by using physical properties like melting point and boiling point. The amount of substances in a mixture can vary, and these amounts don't have a fixed ratio. That means that one substance can be in a higher ratio as compared to other substance. Therefore, even two mixtures containing similar types of substances can be different due to the difference in their mixing ratios. Mixtures can be mainly divided into two types as homogeneous mixtures and heterogeneous mixtures. In a homogeneous mixture, the individual components cannot be separately identified, but in a heterogeneous mixture, the components can be individually identified. In case of a salt in water solution, you can see that it's a homogeneous mixture because we cannot separate individual component. And if we take sand and sugar solution, it is a heterogeneous mixture because the components are identified easily. So this is a difference between homogeneous mixtures and heterogeneous mixtures. We will discuss about solutions. A solution is a homogeneous mixture of two or more substances. It is called a homogeneous mixture because the composition is uniform throughout the solution. The components of a solution are mainly of two types, solutes and the solvent. Solvent dissolve the solutes and form a uniform solution. So normally solvent amount is higher than the solute quantity. Most common solvents are liquids. Among liquids, water is considered as a universal solvent because it can dissolve many substances than any other solvent. So we can say that a solution is a mixture of solute and solvent, and water is considered as a universal solvent. Normally solvent amount is higher than the solute quantity. Gas, solid or any other liquid solute can be dissolved in liquid solvents. In gas solvents, only gas solutes can be dissolved. There is a limit to the amount of solutes that can be added to a certain amount of solvent. The solution is said to be saturated if the maximum amount of solute is added to the solvent. That means if we further add solute to the solvent, then it will not mix in the solvent. That is called a saturated solution. If there is a very low amount of solutes, the solution is diluted. And if there is a high amount of solutes in the solution, it is a concentrated solution. By measuring the concentration of a solution, we can get an idea about the amount of solutes in the solution. So, saturated solution, dilute solution, and concentrated solution. That is the main point here in this particular slide. Next, we have types of solution. So basically, we have two types of solution, homogeneous and heterogeneous. In homogeneous solution, we have solid in liquid, liquid in liquid, and gas in liquid. Solid in liquid, like we have the example of salt in water solution, that is the example of solid in liquid. For liquid in liquid, we have vinegar in water solution. And for gas in liquid, the example is soda water, where carbon dioxide is used in water. And basically heterogeneous, we are having two types, suspension and colloid. Suspension, like we dissolve sand in water, we check that the sand remains suspended in the water. And milk is a very good example of colloid. So points to remember: mixtures are composed of variable proportions of different substances without chemical bonding and have the same properties as that of its component elements. As we have already explained in the previous slides, that the mixture can be homogeneous and heterogeneous also. Homogeneous mixture cannot be identified separately, and we take the example of salt in water solution, and heterogeneous mixture can be identified separately, like we take the example of sugar in sand mixture. Similarly, solution is a homogeneous mixture of two or more substances, and the substances present in the largest amount is called the solvent, and the substance present in smallest amount is called the solute. Also, we have seen that saturated solution, in which further addition of solute cannot be done. Then we have studied the dilute solution, the concentrated solution. Then in case of type of solutions, we have seen that homogeneous solutions are there and heterogeneous solutions are there. In homogeneous solution, we have solid in liquid, liquid in liquid, and then gas in liquid. And in case of heterogeneous solutions, we have suspension and colloid. Further, we have understand these types of solution with the help of examples also. So that's all in today's topic. Thanks.